Hey guys, it's Sukrit from STEM Coder. Today we're going to go over how to reduce a matrix to the reduced row echelon form using the three fundamental row operations. In the last video we talked about how to transform a matrix into the plain echelon form using row operations. Today we're going to take it a step further and transform it into the reduced row echelon form. The process is much more tedious, and in the future I will teach you a bunch of shortcuts as well as a few tips and tricks, so that when we actually come to matrix applications, you won't have to do this too many times. But for now, I am going to teach you the full process, how to reduce a matrix to reduced row echelon form. Let's get started. Now, the process is quite similar to what we had for reducing it to plain echelon form, except that pyramid method, instead of just doing it for the lower half, we're going to do it for the upper half as well. And obviously, if it's a 4x4 or a 5x5 matrix, the process is going to be similar, except we'll just be expand our pyramid. Recall that a matrix can be in reduced row echelon form, even if it's not square. And in that case, you kind of have to play around with it a bit. For example, if you have maybe a 3x2 matrix, maybe try reducing these and then try reducing that. Obviously, you're not going to have a square matrix every time, but now we're going to practice using a square matrix. Let's get started. We first want to reduce this 3 to a 0. So how do we do that? Why not add -3 times the first row? So row 2 goes to row 2 plus -3 row 1. When we do that, we'll get, well, row 1 stays the same, row 3 stays the same, and to row 2, 3, 0, 2 plus -3, 3, -6, we're going to add that. We end up getting 0, 3, -4. So 0, 3, -4. Now we want to reduce this element, this 1, to a 0. How do we do that? Well, why not subtract the first row? So let's do that. Let's do row 3 plus -1 times row 1. So I'm adding -1 times the first row to the third row. What do we get? Well, let's do it. It's just 1 plus -1 is 0, -3 minus -1 is -2, and -1 minus 2 is -3. Just check that again. -1, -3, -1, then -1, 1, -2, 0, -2, -3. Remember that adding -1 is the same as subtracting. So now we want to reduce this -2. So how do we do that? Well, why not subtract 2 times the first row? So we want to do row 3 goes to row 3 minus 2 row 1. So row 1 stays the same as usual, 1, -1, 2, 0, 3, -4. And now for row 3, we'll add 0, -2, -3. 2 times that is 2, -2, 4. Add it up, we get, and we see a problem, right? We cannot just add 2 times the first row in this case. We gotta add a multiple of the third row, or of the second row, sorry. But look, it's not going to be an integer calculation. Clearly, no matter what we multiply 3 by, we cannot multiply 3 by an integer to basically cancel out this 2. So unfortunately, we will have to use decimal numbers. I'm going to add 2/3 times the second row. So row 3 goes to 2/3 row 2 plus row 3. See, we tried it out with this one, but obviously it doesn't work because this 1 over here is going to ruin this 0. So instead, what I'm doing is multiplying the second row by 2/3 and adding it to the third row. We cannot do anything with the first row because this 1 is going to ruin this. 1 is going to, no matter what you multiply it by, this 0 is not going to be there anymore. So we want to preserve this 0. So that's why you got to take a multiple of this row. And let's do that. So we're going to have 0, 0. What is -4 times 2/3? That's going to be -8/3. -8/3 minus 3, that's going to be -8 minus 9, -17 over 3. So -17 over 3. I know it's an ugly number, but remember, totally this process is going to get ugly. Let's continue. Now we want to work our way up again. So we want to get this 4, then this 2, then this 1. Let's try it out. So I have 0, 0, -17 over 3. 0, 3, negative 4, and what is it? 1, negative 1, 2. Somehow I want to use this 17 thirds to cancel out this 4. How do you think I'm going to do that? Well, why not multiply this number by 3 over 17 times 4. If I multiply this by this third row by that, I can cancel out this negative 4. So let's try that out. You'll find out that because everything else is a 0, I'm just going to multiply this third row by 3 divided by 17 over 4. Sorry, negative 3 divided by 17 over 4 and add it to the second row. So when that happens, so my second row is now going to be, so row 2 goes to row 2 plus negative 3 times 4 over 17, row 3. I end up getting this 1, negative 1, 2, 0, 3, 0, 0, 0, negative 17 over 3. Not quite ugly, right? It's not as ugly anymore. Once again, now we need to cancel out this 2. And how will I do that? Well, I can try multiplying this third row by negative 3 over 17 times 2. I'm sorry, just by positive 3 over 17 times 2 and adding it to the first row. So let's do that. Remember, these two are 0, so these two numbers will remain unchanged. This will become a 0, so it makes the calculation slightly easier. So row 2 goes to, row 1 goes to, row 1 plus 3 over 17 times 2, row 3. When that happens, we get 1, negative 1, 0, 0, 3, 0, 0, 0, negative 17 over 3. Remember, I just tried to multiply this row so that I get 0, 0, negative 2 here. And I can just add it to the first row. We're almost done. We just have this last element. And I need to just add 1/3 times the second row to the first row. So let's do that. So I want to do row 1 goes to row 1 plus 1/3 row 3. Sorry, row 1/3 row 2. And I get 1, 0, 0, 0, 3, 0, 0, 0, negative 17 over 3. Now just tell me, okay, is this in echelon form? It is in echelon form. Is this in RREF? No, it is not, because I need to have all my leading elements be 1. But that's not hard. We have our scale operation over here. Scale. Why don't we just multiply the second row by 1/3 and the third row by negative 3 over 17. So let's do that over here. So I'm going to multiply row 2 is 1/3 row 2. So I get 1, 0, 0, 0, 1, 0, 0, 0, negative 17 over 3. And finally, I'm going to multiply row 3 goes to negative 3 over 17 row 3. And now we're going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. Voila! This is in reduced row echelon form. So the math may have been a bit ugly, but we worked our way around. We did this one, this one, this one, this one, this one, this one. We tried making those zeros. And once that happened, all we had to do was multiply or scale these rows such that we end up with ones in the diagonal. All I had to do is some scaling, that's it. So you may have noticed something over here, okay? Look, when our matrix is in for this form, which is by the way called the upper triangular form, because our bottom triangle, that's all zeros. When it's here, you may have noticed that our diagonal didn't actually change. I was just able to get rid of this negative 1, this negative 2, negative 1, this negative 2, and this negative 4. So that's a neat thing that happens with these kinds of matrices when you have like a square matrix and you have zeros on the bottom. But when you have rectangular matrices, that's not always the case. And I have a rectangular matrix over there where it won't necessarily be this nice where this diagonal gets preserved where you're doing this row operations. It may get a bit uglier. So let's work this out. So I have this matrix over here, excuse me. Negative 1, 1, negative 1, 0, 0, negative 1, negative 1, 4. How will you reduce that to RREF? Maybe pause the video and try to figure this out. Well, what we have to do is, maybe first step, add negative 4 times the third row to the fourth row, so you'll end up with this. I'm taking some shortcuts here. So just add negative 4 times the third row to the fourth row, so you'll end up with this. Now, add negative 1 times the fourth row to the second row, because to get this. sorry, other way around, add -1 times the second row to the fourth row to get this. Okay, good. So once again, I'm using intuition here. I'm not exactly following that roundabout pyramid fashion. I mean, these rectangular matrices can get kind of tricky. And now I'm almost there. Why don't I try adding the third row to the first row? So if I add the third row to the first row, I get -1, 0, -1, 0, 0, -1, 0, 0. Almost there. Why don't I try adding -1 times the second row to the first row so I can eliminate the first row, effectively all zeros. So I get 0, 0, -1, 0, 0, -1, 0, 0. And finally, I can basically swap the second and first rows and then swap the third and second rows. So just do some swapping over here. And finally, one more swapping. And this matrix, and finally, I want to multiply both these rows by -1, so I have ones diagonals. And so I'm just doing both of them at once. Now I kind of took a shortcut, but look, lot of operations here. You see what I did? I kind of just used my own intuition, trying to just get rid of the rows bit by bit. So I hope you enjoyed this video. I know that it's a lot of information to take in, but once again, you gotta just practice and use your intuition. Sometimes you can use this roundabout method. So not just a pyramid, but kind of just go around. So do the pyramid here and then an upside down pyramid on that side in order to reduce a matrix to reduced row echelon form. Sometimes if you have a rectangular matrix, you just got to use your intuition. Just think, which rows can I easily reduce to a 0? Which rows can I eliminate easily? And once you figure that out, just go ahead, do the row operations, experiment a bit, and eventually you're going to end up reducing it to reduced row echelon form. It's a lot of, I know it's a lot, quite difficult, but practice, practice, practice. Do a lot of practice problems. In the future, when we're actually applying these matrix reductions and transformations, we'll try to use some shortcuts so that we don't have to go through this whole process, but it's just nice to know how to reduce a matrix to reduced row echelon form. I look forward to seeing you guys in future videos.